Hello everyone, I'm Himanshu and today we'll go towards solving some of the questions related to trees, and we are using right now NEET code blind 75 problems. And yeah, let's start with tree. So let's start with binary tree level order traversal question. Okay, so this is binary tree level order traversal. So what does it mean? So given a binary root. So what we have to return the level order traversal of it as a nested list. Okay, so output should be in the form of list, where each sublist contains the value of nodes at a particular level in a tree from left to the right. Okay, all right. So if you see here in the output for this input, it says 1 because it is on the first level. Then there is 2 and 3, and then there is 4, 5, 6, 7. All right. So once I understand the question, one thing that is coming to my mind is the output should be list, that is correct, and we have to traverse through the tree, level by level. So and after each level we will push the results on our return list, and after each level we need to push results to the output list. So yeah, this is how does it looks like. So now if we move forward, so for the implementation, so what I think, how can we implement is, number one step is to yeah, number one step is to use or input just one, and then try to check what are the children's associated with one. That will give us two and three, and then look at what are the childrens that are associated with 2 and 3, which will give us 4, 5, 4, 5, 6, and 7. Okay, so this is what the order of pushing to the list will be. So I think this is uh, done by queue. So we will be implementing the queue, and what we will do in the queue is that we will use queue for input of the root node, and then we will find like what are the children associated with this, and then we will then traverse the queue until the queue is empty. So yeah, let's start. First, let's see how to declare a queue in Python. So I'll just quickly ask ChatGPT uh, how to use queue in Python. uh, Tell me syntax for all the queue operation. So let's push this and let's see what I will be getting here. So yeah, there is collection. So okay, so queue is declared using dequeue. So you have to from collection we have to import dequeue. Okay, it is created like this. Then there is okay q0, peek back is q minus 1, pop left in queue. So in the queue, one way it comes, the second way is as it goes out. So it's like append and pop left. Okay. Empty, just check the length, and remove back is pop, and clear is a to the front is append left. Okay, so it's basically it is a DQ in which you can just uh, append from both the side. So Q pop is pop back. So let's check here 10, 20, and 30 are implemented. So we will 10, 20, and 30. And then we have print Q0, which is the 10. And when we pop left, uh, and we'll print X, so it will be 20 and 30. So since it is Q, the one that has appended first has will be the one who will be uh, getting removed from the list or the queue, which means that this is the operation that we are using, that is x equal to q dot pop left. I see. So for our case, I think these two q dot pop left and q dot append will be the two commands that will be using mostly. And dot get, what does it do? Put. Mm, okay, there's also from q. We can import q and we can do put. We can get. We can check if it's empty. Priority queue is like from queue only. We can import the priority queue and we can put 5 1 3. So pq dot get, what we'll get is the 1. So heap. Okay, heap is just import heap and then can use this operator. Okay, so queue using Python list. So just implement a queue and that's append and dq is O of pop. Okay, this is O of 1. So from the coding interviews, just doing the pop left and appending would be the good option. So let's move to the question. So yeah, we will declare this first will be equal to dq. Dq. Check if my spelling is correct. It's dq. Yeah, we have to import from collections, right? So let's just put this on the top. Port dq, import dq from collections, right? Import collection from collections, import dq. Okay, I see. So from collections we have imported dq and now we have declared q to be dq, and now what we'll do is we will just append in q, we'll append the root. This is what is done here, and now which means that now we have 1 here and now we have to run a loop which will be while not q, that while q is not empty. What we'll do is we will take node which will be equal to q dot which will be equal to q dot pop left, right? Now we have node here, and then in the queue, uh, yeah, and we will maintain a list of the results that we'll be outputting. Uh, Also, we will be having a list of temp. So what this temp will handle, it will so this temp will handle all the, all the node till that queue. Yeah, and yeah, we'll just take the node, and what we will do is uh, okay, so at each level we have to take the output and then we have to uh, put. So what we can do is okay, while the queue is not empty, uh, here we have to go through all of the elements in the queue, elements in the queue. Yeah, so yeah, while the queue is not empty, what we can do is uh, we can declare a temp here. So temp will be declared here, and then for now we have to check. Yeah. So for I in range length of queue, we'll just check what is the size of queue, and for all the length of the queue, we'll just input. What we'll do is uh, we'll take the node which will be uh, equal to q dot top left. So we'll be taking the left element, and after taking the left element, we will just push the element into temp. So which will be temp dot attempt and append node. So now the temp has one more node, and so yeah, that's correct. So for because the size of queue is this, so it will take all of these, and yeah, that will work perfectly fine. So now since we're taking from the top left, we are popping it. Now we are appending it here. Uh, yeah. So yes, we can also do temp dot. Yeah, we have appended this. So it has all the elements. We have taken out the element and we are appending the element in the node. All right. And from here, what we'll do, we'll also append the left and right into the queue. So which means queue dot append node dot left, and we'll also append q dot append node dot right. So for all these nodes, we'll just append these two parts, right? All right. And once it is done, we'll just update res dot append temp. So we'll just enter the temp to here, and then finally we will just return the res. So yeah, I think this is my method. So I've declared a queue. I have inserted the root inside it. Uh, len of queue I think will not be appropriate here. So instead, what we can do, I can find the len of queue here, because the length of, since we are also appending, the length of queue will be dynamic, right? So it's better to use length of queue here, and for all of these, you just pop left. It will append the node in the temp, and then it will just append left and right. Yeah, and finally we are just append. Okay, I think this should work. Okay, let's see what is the error here. Your output is this, meaning that we are not able to inserting. Looks like this. Okay, like this. Now let me check why the rest I'm not able to append. So temp dot append is node. That is okay. Okay, the output is in the form of integer. So node dot wall, node dot wall is something that will be appending, right? Left and right. Yeah, the output is this only. Not able to. Okay, while not Q. It is not even going here. So let's print function. Not coming, right? So yeah, so this is it, but While not Q. While Q, right? Yeah, I think they should work. So what is the difference between these is that I have already inserted this, right? Except that there's no issue. Okay, correct. So let's just comment this and move this and then done. The object type has no attribute fall. Node, what is this then? Node. What is the attribute then for the value? It's wall, right? Node fall. What is the issue here? Terminal append node dot fall. Node is not defined. Node is defined, and node has a value, right? Okay, that is correct. Okay, it's just waiting for the third case. What is the input here? Input is nothing. So should expect nothing as well. So you can just check, right, if I'm losing it. Just cut it here and then just paste it here, and you can just see if root is none. Just return this. No need. Let's submit. Yeah, it's got pass, and let's just look at the solution for once. Hmm, took us some time. I mean, complexity is O1, space complexity O1, how it was done. So they have created a DQ, collections.dq. They have appended a root q len. Okay, they have taken the length as we have taken, and here they create a lot temp. They've gone through n, hit pop left, and the if node is there. Okay, that is also a good strategy. If node is there, then just append node dot left, node dot wall, and if level, uh yeah, like if the level have something, then only append this something. So in this way, what, even if the null is coming here, right? So nothing will go there, and the level will also there, so it will just append the level. Yeah, I think that's nice. Similar and similar implementation. Yeah. So yeah, that's all. Let's take a break. We'll see you later. Bye.